9.3, solving quadratic equations using square roots. Okay, so the core concept here will be the solution of x squared equals d. If you recall in 9.1, we studied properties of square roots. Now we use those square roots to solve quadratic equations of the form ax squared plus c equals 0. We first need to isolate ax on one side of the equation to obtain x squared equals d. Okay, so remember, we need to isolate x squared to have x squared equals d. Then solve by taking the square root on each side. But before we do that, remember the core concept is going to be if d, okay, so here, if d is greater than 0, then we're going to have two real solutions where x is going to be plus or minus the square of d. If d equals to 0, therefore, that means that we're only going to have one real solution, and x will equal 0 unless it's specified, and then we'll just have one real solution where x equals number. If d is less than 0, then we have no real solution, okay? So think of these as your negative numbers, but only when you're left with x squared equals, let's say, this is an example, negative 2. If we look at here, negative 2, if I was to square that, there's nothing that's going to give me two negative numbers. If I was to square this, negative 2 to give me negative 2, no two numbers or two factors will give me negative 2. Even if it was x squared equals, let's say, negative 9. We know the square of 9 is 3, but if I would square root this, nothing will give me negative 9 inside. Solving quadratic equations using the square root. So remember, the first thing we want to do is to isolate. So we have 3x squared minus 27 equals 0. Remember, we're isolating where x squared equals d. I'm going to add 27 to both sides. So we're going to have this step first. We're left with 3x squared equals 27. Then I'm going to divide by 3 because remember, we're isolating x squared. If I divide by 3, I'm left with x squared equals 9. So what I would do is, if you want, circle the 9, which is d, and determine if d is going to be greater than, less than, or equal to 0. In this case, d is 9, so d is greater. That means we're going to have a plus or minus that we're going to take to square root. So if I square this, we're left with x squared equals plus or minus 3. And that is our answer. In B, we have x squared minus 10 equals negative 10. Let me fix this. 0, x, negative 10. If I add 10 to both sides, I'm left with x squared. So it's x squared is actually already isolated, equals 0. I take this determined if d is greater than, less than, or equal to 0. This is equal. That means I'm just going to have one real solution. And if I square this, I have x equals 0. And that's my answer. In C, we have negative 5x squared plus 11 equals 16. If I subtract 11 from both sides, I'm left with negative 5x squared equals 5. If I divide by negative 5, x squared equals negative 1. I'm going to determine if my d is less than or equal to or less than 0. In this case, we know this is less than d, which is the negative 1, is less than 0. Therefore, this cannot, remember, the square cannot be negative. So the equation has no real solution. Solving a quadratic equation using square roots. So if you notice, remember before, we need to make sure that we isolate x squared correct, equals D. In this case, we have a parentheses, correct? But you could still see that this is in a way kind of isolated because this is by itself, correct? X minus 1 is within the parenthesis in itself, and that is going to be squared. So I can X minus 1 squared equals 25. I'm going to square this, which gives me X minus 1, because remember, there's an imaginary 2 in this index. That means that these is going to cancel out. We have X minus 1 equals, but before I determine that, D is going to be what? Greater than 0. So I'm going to have a plus or minus. So I'm going to have X minus 1 plus or minus square root of 25 is going to be 5. Now I'm going to separate because it's telling me that I have an X minus 1 equals 5 and X minus 1 equals negative 5. So I'm solving for 2. Plus 1 on both sides, X equals 6. X equals negative 4. And those are both my answers. Solving a real-life problem. A touch tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cube feet. Find the length and the width. So we know that the formula of a volume is length times width times height. Given this information on this word problem, we know that the touch tank has a height of 3 feet. So we know that the height is, if I plug in, I'm going to have 3 somewhere here for H, correct? Its length is 3 times its width. So we know that the length, different colors so you guys can see it, 3 times its length is 3 times its width. So we know that it's going to be 3 times its width. I'm going to put it in parentheses. So this is my length. We do not know the width because they're asking us to find length and width. So I'm going to solve for W, also width and length that they're telling us to look for. And we know that the entire volume is 270. So I'm going to start working this out, and I'm left with 270 equals 3. Okay, this is 3 times W gives me 3W squared. Right? Times 3 for the height. 270 equals 9W squared. If I divide by 9 to start isolating the W squared is like that's the X squared where you are solving for the square, isolating it. So we left with W squared equals 30. We know that 30 is going to be greater than 0, so we're going to have a plus or minus. Oop, I put plus 1. Plus or minus, correct? So in this case, once I square this, I have plus or minus radical of 30 equals W. I'm going to have you guys leave it like this. There's no need to find the approximate, okay? Because we know that 30 is not a perfect square. So let's just do some extra process here. Solve the equation using square roots. I divide by negative 3. I know that you could think, oh, it's already no solution because D is negative, but there is a coefficient here with the X, correct? So that means I still need to isolate for X squared. So I'm going to divide by negative 3. Let me write this 3 later. So I'm left with positive X squared equals positive 25. We know that 25 is going to be greater, right? D is greater, so we're going to have a plus or minus. I'm going to finally square X equals plus or minus 5. Number 2, I'm going to move over 12 on the other side, and I'm left with X squared equals negative 12. I can see here that D is going to be less than 0. Therefore, no real solution. Number 3, I'm going to add 15 to both sides. I'm left with 4x squared equals 0. Now I'm going to divide by 4, and I have isolated my x squared, right? X squared equals 0. D equals to 0. That means I'm going to have only one real solution. If I square this, I'm left with x equals 0. Continue with some practice. I can see that this is already isolated. I'm just going to square it. And I know that 0, highlight another color, 0 equals, correct? D equals to 0. So I'm left with x. That means I'm just going to have one solution, okay? One real solution. X plus 7 equals 0. Subtract 7 from both sides. X equals negative 7, my one solution. Number 5, if you have a number in front of this, it means please do not distribute, okay? This just means that you have 4 times x minus 3 squared, okay? So what you're going to do is divide by 4 so you can leave x minus 3 squared equals 9 over 4. Now I'm able to square it, but I could determine that D is greater than 0, so I'm going to have a plus or minus. If I was to square this, I'm going to be left with x minus 3 equals 3 plus or minus 3 over 2, because the perfect square of 9 is 3 and the perfect square of 4 is 2. So now I'm able to separate all this, right? So I'm going to have x minus 3 equals 3 over 2, and x minus 3 equals negative 3 over 2. If I add 3 on both sides, I'm left with x equals 3 plus 3 over 2. Therefore, x equals 3 times 2 is 6. 6 plus 3 gives me 9 over 2. It's my first x, correct? And my second one, I'm going to add 3 again. So I'm going to be left with x equals 3 minus 3 over 2. 3 times 2 is 6. And 6 minus 3, it's going to give me 3 over 2. In number 6, I can square it right away. So I'm going to have 2x plus 1. And we know that D is greater than 0. So we have a plus or minus. Plus or minus 6. So I'm finally going to make two equations. 2x plus 1 equals 6. 2x plus 1 equals negative 6. If I subtract 1 from both sides, I'm left with 2x equals 5 divided by 2. X equals 5 over 2. If I subtract again to the other side, the minus 1, I'm left with 2x equals negative 7 divided by 2. I'm left with x equals negative 7 over 2.